So the next instruction that I'll be discussing under logic set group is CMPR. So CMPR it will work the same way as the subtraction instruction, but the only difference is the result will not get stored in the accumulator, but it will get discarded. So again I'm repeating what will happen. Suppose here R is representing the register. So what will happen? Suppose CMP, you can take any register. Here I'm taking register B. So what will this instruction do? It will subtract the content of register B from the content of accumulator, and the result, and as per the result the flags will get affected, but the result will not get stored in the accumulator, it will get discarded. So the result will be discarded. So you can say that before and after the execution of this instruction, the content of accumulator will remain same. There will be no change in the content of accumulator. So again I'm repeating what is happening here in this instruction. The content of the mentioned register will get subtracted from the content of the accumulator, and as per the result what will happen? The flags will get affected, and the result will get discarded. Now how flags affected? Obviously all flags will get affected. Number of bytes for this instruction, as there is no hexadecimal number mentioned along with this instruction, so number of bytes will be 1 only, and that is for opcode. Machine cycle for this instruction will need only one machine cycle. How? That is for opcode fetch. So first machine cycle will be used for opcode fetch. After fetching the opcode and decoding it, microprocessor will get to know that it has to subtract the contents of the mentioned register from the content of the accumulator. So both the accumulator and the register is present inside the microprocessor, so it will not need any extra machine cycle for memory read or memory write or for executing the instructions. So one machine cycle is enough for executing this whole instruction. Now T states, obviously this opcode fetch machine cycle has 4 T states, so it will need 4 T states only for complete execution. Addressing mode, here the operand is the content of accumulator or the mentioned register, so these two are the registers only, so the addressing mode is register addressing mode. Now next instruction in this group is CMPM. So CMPM, what this instruction do here? M is the memory location pointed out by HL pair. So what this instruction do? It is just the same as CMPR. Here what is happening? The content of memory location is getting subtracted from the content of accumulator, and according to the result the flags are getting affected and the result is discarded. So what is the memory location? Again I am repeating here, HL, the content of HL pair will tell you the address, that is the memory location address, and what will happen? The content of HL pair is the memory location address, and the content of that memory location, will get subtracted from the accumulator, and according to the result the flags will get affected and the result will get discarded. That is, before and after the execution of this instruction there will not be any change in the content of the accumulator. Flags affected, obviously all flags will get affected. All flags will get affected, and the number of bytes in the instruction, as this instruction does not have any hexadecimal number mentioned along with this instruction, so the number of bytes is 1 byte only, that is for opcode. Machine cycle, it will need 2 machine cycles, 1 machine cycle for opcode fetch. So after fetching the opcode and decoding it, microprocessor will get to know that it has to subtract the content of memory location pointed out by HL pair from the content of accumulator. So at this stage microprocessor is having the content of accumulator, it is having the address, that is memory location address, which is the HL pair content only, but it does not have the content of that memory location address. So second machine cycle will be used for memory read, that is for reading the content of the memory location and executing the whole instruction. Now T states, how many T states? So opcode fetch machine cycle has 4 T states and memory read has 3 T states. So all total 7 T states it needs. Addressing mode, since here the operand's address is indirectly specified by the actual register pair. So the addressing mode is register indirect addressing mode. Now the next instruction is CPI data, CPI 8-bit data. Again, it is the same operation, just like the previous instructions as I've discussed. So again, this instruction, what it will do, it will subtract the 8-bit data, mentioned 8-bit data from the accumulator content, and according to the result, the flags will get affected and the result will get discarded. So here again, all flags will get affected. Number of bytes, since it is having 1 byte hexadecimal number mentioned along with the instruction, so the number of bytes will be 2, 1 for opcode and 1 for this 8-bit data mentioned here. Machine cycle, it will need 2 machine cycles. First machine cycle for opcode fetch. After fetching the opcode and decoding it, microprocessor will get to know that it has to subtract certain 8-bit data that is stored in the memory from the content of the accumulator. So the second machine cycle will be used for memory read, that is for reading that 8-bit data and executing the instructions. So our total 2 machine cycles. T states, obviously opcode fetch machine cycle has 4 T states, memory read has 3 T states, so all total T states is 7 T states. Addressing mode, since the 8-bit data or the operand is directly mentioned in the instruction, so the addressing mode is immediate addressing mode. So these all 3 instructions were the comparison instructions. Now the next instruction is STC instruction. STC instruction means set the carry flag. So whenever this instruction gets executed, whatever be the status of carry flag, the carry flag after executing the instruction will get set, that is its status will be 1. Now flags affected, obviously it is affecting the carry flag, so flags affected will be 1. Number of bytes, obviously it is a 1 byte instruction because no hexadecimal number is mentioned along with this instruction, so number of bytes is 1. Machine cycle, obviously 1 machine cycle it will need, that is for that too for opcode fetch. So after fetching the opcode and decoding it, microprocessor will get to know that it has to set the content of the it has to set the carry flag. So carry flag is within the microprocessor, so it does not need any extra machine cycles for executing the instruction. So machine cycle will be 1 only. 1 machine cycle is enough for executing the instruction. T states, obviously opcode fetch machine cycle has 4 T states, so it will need 4 T states. Addressing mode not mentioned here for this instruction. Now the next instruction is CMC instruction. Next instruction is CMC instruction. So what CMC instruction does, it means complements the carry flag. So whatever be the status of carry flag after executing the instruction, the carry flag content will get complemented. That is, if previously carry flag was having 0 status, so after executing the instruction its status will be 1, and vice versa. So flags affected, obviously it is affecting the carry flag, so flags affected will be carry flag only. Number of bytes, so again number of bytes for this instruction, there is no hexadecimal number mentioned along with this instruction, so number of bytes will be 1. Machine cycle, obviously 1 machine cycle, that is for fetching the opcode. So after fetching the opcode and decoding it, microprocessor will get to know that it has to complement the content of carry flag, and carry flag is present inside the microprocessor, so it does not need any extra machine cycles for executing the instruction. So 1 machine cycle is enough. T states, obviously opcode fetch machine cycle has 4 T states, so it will need 4 T states. Addressing mode, no addressing mode mentioned here. Now the last instruction of this logic group, is CMA, that is complement each bit of the accumulator. So see, whatever is the content of the accumulator after execution of this instruction, accumulator contents will be complemented. That is, if the content of the accumulator is suppose 30H, so in binary form, how you will write, 0 will be written as 0000 and 3 will be written as 0011. So after execution of this instruction, what will happen? Each bit will get complemented of the accumulator. That is, 0 will get complemented by 1, 0 will get complemented by 1, 1, and 1 will get complemented by 0. And this result will get stored in the accumulator. Flags affected, no flags will get affected as it is just as it is just affecting the as it is just affecting the content of the accumulator. Now number of bytes for this instruction, as it does not have any hexadecimal number mentioned here, so number of bytes will be 1. Machine cycle, obviously it will need 1 machine cycle, that too for opcode fetch, that is after fetching the opcode and decoding it, microprocessor will get to know that it has to complement the contents of the accumulator, and the accumulator is present inside the microprocessor, so it does not need any extra machine cycles for executing this instruction. So 1 machine cycle is enough, that is for opcode fetch. T states, obviously opcode fetch machine cycle has 4 T states, so it will need 4 T states only. Addressing mode, since here the content of the accumulator is the only operand on which the operation is being performed, so the addressing mode here is implicit addressing mode. So here the logic group instructions is completed. In the next lecture I'll be starting with rotate group instructions. I'm ending this class here. Thank you.